Hi, everyone. I'm Amber Thomas. I'm the community lead here at data.world.
And I'm Dean Alamang. I'm the Principal Solutions Architect at data.world.
As you may have been gathering from some of the other talks you've heard today, including the one that played right before this, data.world is very focused on data, and we're also a public benefit corporation and a certified B Corp, which means that some aspect of what we do is all about making the world a better place. So we're going to talk a little bit today about one of the projects that we've been working on within data.world to enhance the world of data. So before we jump too far into that, I do want to give a little brief overview of something that I mentioned in my last talk. So if you were here the past 30 minutes or so, you will probably have seen this. If you missed it, no worries. I'll give you a brief overview right now. Wonderful. So this is a concept called apologies. There we go. 5-star open data. And this is something that was presented by Sir Tim Berners-Lee, and it's an idea of how to assess how open data that you're sharing on the internet is. And so there are 5 levels of this. And the first star means that it's data that's now available on the internet. It ideally has an open license so that it can be legally used. It's made of structured data. It's in a non-proprietary data format like a CSV or a JSON. We use URIs that are globally unique to represent things, and then we use those URIs to link data together. Now, again, if you missed my last talk, no worries at all. You're going to see a lot of this throughout this talk. But Dean and I have been working on a project here at data.world to really open up a source of data that's already kind of open, but could be a lot more useful. And we really want to walk you through what that process has looked like so far. So, for a little bit of background, a few years ago, the Center for Medicare and Medicaid Services here in the US released a ruling that hospitals across the country now have to publicly release standard charges. That is how much money you pay for specific goods or services rendered at a specific hospital. Now, these vary a lot based on whether you're paying with cash or if you have various insurance plans and so on and so forth. But the CMS was requesting that hospitals now publicly release this data. And this seems like a really great thing. If you've ever tried to get medical care here in the US, figuring out how much that's going to cost is hard. So the fact that people are now releasing data is potentially really great. And what actually excited us a lot about this was this ruling actually requires hospitals to release standard charges, both in a consumer-friendly format and in a machine-readable file. So what that means is there's all sorts of files that meet some level of open data now available, and we wanted to combine them, put them all in one place, because it turns out that all of these hospitals have all of these files scattered on their own hospital websites. We ended up being able to pull in a lot of data, but it required using a source called Wikidata, a custom Node JavaScript web scraper, and the data.world API to even get some of those files in a place where we could work with them. That's a story for another day, but trust me, it was a little bit of work. But what we started to discover when we were looking at these data files that we found was that they were all in technically a machine-readable format, but they were formatted very differently. It would be really hard for you to use a standard join between tables because each column was labeled differently. Some tables were arranged in a wide format and others in a long format. It was honestly very messy. But one thing we noticed was that a lot of different hospitals, which is what you're seeing here, these are the files from 3 different hospitals, they're using the same sort of standardized code systems. And these are common billing codes used throughout the US. So we decided to lean in that area.
So if you look at these codes of this sort are sort of the join points in open data on the web. So here's 4 of them that we're looking at here, a thing called HCPCS, CPT, NDC, MSDRG. These are all sponsored either by government or some sort of an industry agency and they are published specifically for the purpose of allowing people to take data sets from different sources and have them make common references so that we can cross-reference things. Now, one of the problems that'll happen, next slide, please, is that some of them, people have a business model around these things. And so they have copyrights or billing models where you need to pay to use them. And this really sort of squelches the idea of having open data interacting freely on the web, which is what we're sort of accustomed to with documents on the web. So, but nevertheless, let's go to the next one. We're going to focus on a particular one of these codes, the HCPCS code. And if you look at this particular data set from Mayo, we see the way that they refer to an HCPCS code is that they have one column for all of their codes. And in that column, they put a little bit of extra information at the start of HCPCS. And if you go through this column, you'll see NDT, NDC, and MSDRG, and so on for other kinds of codes in order to refer to that code. Now, to figure this out, you need to look at this, write a little piece of program that figures out that this is an HCPCS code, and then look up stuff about that. And that's what we're going to look into in the next couple of slides.
Exactly. So when we were trying to figure out how to decode these HCPCS codes, again, these are codes that are used across the medical industry, the Center for Medicare and Medicaid Services does release a sort of code book to better understand what all of these different codes mean. But the HCPCS code is one big code that's associated with many other smaller codes. So each HCPCS code might be associated with a specific code that shows what kind of lab certifications are required for that good or service that is denoted by the original code. So we have like lots of layers of codes that we were trying to tease apart here. And what you can see on the screen here is the text file that the Center for Medicare and Medicaid Services released to describe what all of these codes mean. Now, as far as our stars of open data go, this was available on the internet. It had an open license. It was in a non-proprietary data format, kind of. It's a text file, which is non-proprietary, but it did allow the folks who created this to share the data in a very unstructured way, which means that it was actually kind of hard to parse, both as a person and pretty much impossible for a computer to parse. So our next step was to take this information and first move it to a structured data format. In this case, we decided to move it to a CSV. So we took all of the information from the text file and put it into a more tabular format. Now we're up to 3 stars of data. That's pretty great. We would like to move on to the 4th star of data, which is adding a URI or a yes, exactly, right on the mug. It's all right there. So we're adding URIs to denote specific things within our CSV file, and we'll end up moving out of CSV into another format. Now, we're going to use the example. We'll focus in right here on one particular example of virology. This is a lab certification that you saw in the text file, and we're going to come back to this. Now, a quick aside, you're going to be seeing us talk about and show bits of RDF code, which is a language of sorts. And the way that we created this was using a Sparkle query engine within data.world. So we're going to be showing you a lot of things. Some of this was written manually, but most of it was generated via a code directly in data.world, and we share the results through data.world as well. All right, time to decode the URI. So what we're trying to do here is come up with a unique identifier for each one of these lab certification codes. And so this string that you see here looks a lot like a web URL, is the URI we landed on. Dean, would you like to talk a little bit about how we got to this structure?
Yeah, so you need to understand that the little snippet you're seeing here, microbiology, and then the 6 things underneath it, is actually part of one of these mini codes that Amber was talking about. And that mini code is about lab certifications. Inside of lab certifications, there are certifications about microbiology, and inside of that, a particular certification about virology. Now, to have a URI, that is a identifier on the web and should be unique across the web. Oh my gosh, unique in the entire web? That sounds like an awfully big onus, but it actually isn't. Every URL that you use for any page is also unique across the web. How does it work? Well, if you look into this one, let's start with at the right, that L140, that number 140 is actually guaranteed to be unique within this little code. So now our uniqueness is the little code. Lab certification code, that's talking about which code it is. That's unique across all of the little HCPCS codes. HCPCS, again, moving a little bit to the left, this code is unique amongst codes that are published all around the world. But we're going to talk about those codes in a way that is our way of talking about these codes, and that's where the domain comes in. Now here you see spec.edmcouncil.org. So if we do this at data.world, it's going to look like we're making our own data.world map of the universe, and we're telling you what to do. Telling people what to do doesn't work very well on a web scale. But what you can do is to have standards organizations say, this is a standard way to do things that we put our name behind. And if you want to be with our standards, this is our recommendation. And the EDM Council, that's the Enterprise Data Management Council, is a partner of data.world. And this is exactly the sort of thing they do. So to read this whole thing, we're saying this is the Enterprise Data Council recommendation of how to talk about HCPCS. Inside of HCPCS, there is a certain mini vocabulary called lab certification code. And in there is a particular code that is numbered 140. And on the little legend here, we see virology. Now, what you can't tell from this code is that it's virology or that's part of microbiology. All we're doing here is identifying it. What we're going to do next is that Amber's going to show how we can take that other information about this code and represent it in a shareable, uniform way.
Amazing. So yeah, here's all of the information that Dean just mentioned that we know about this code 140 that's labeled virology. So we know it's a lab certification code because it was labeled under that section in the original text file. It's telling us that the code for it is 140. The label that we can use in plain English is called virology, and it's nested under this larger category of microbiology. So if we want to put that into another format, in this case, express it via RDF, it would look like this. So this is basically saying in code the exact same things. This is a type of lab certification code. It has a notation of 140, a label of virology, and it's under the broader concept of microbiology. Now, we can do this one step better. In this case, we're saying this is under the broader sort of umbrella of microbiology as a string, the word microbiology, but instead, we can also use a URI for microbiology. That is structured in the same way as the URI we created for virology, but this will allow us to go to the microbiology URI, and we'll be able to see all of the codes that fall underneath it. So not just virology, we'll also see bacteriology, mycobacteriology, and so on and so forth. So this is a way for us to really connect all of this information in a sort of contextual way that makes sense to our brains, but is really hard to sort of format in a tabular way. So going back to the original Mayo data, we weren't looking at lab certification codes. We were looking at HCPCS codes, which again are a level above things like the lab certification codes. So we need to go one level more and define HCPCS codes. So we'll use this C1776 as an example, and we're structuring this in the same way that we did before. Dean, you want to walk us through the uniqueness once again?
Sure. So this is following the very same structure that we talked about before. So this is a particular HCPCS code, number C1776. And again, we're going to look at that URI from the right to left. This is actually an HCPCS code. It's not a lab certification code, but that's still part of the coding system of the edmcouncil.org. We're using their same authority to do this. And just as Amber showed before, there's information about this particular code. In this case, its notation is C1776, and its long label is joint device implantable. Now, if we go on to the next one.
Oops, sorry. How did I click away from that? Apologies, y'all. I lost my mouse on multiple monitors. Ooh,
there we go.
Way too far. There we go.
There we are. So now we can take this same idea and we can keep doing it. So Amber showed before how we had a link off to microbiology, and we replaced that with not the word microbiology, but a reference for microbiology, a URI. Do the same thing here. If you go through the Mayo spreadsheet, which has dozens of columns, there are columns that describe price descriptions, and the price descriptions are actually done as ranges. A thing called the BTOS type code, and this is a way of describing certain kinds of hospital procedures. CMS types, a code change described in this way. There are all of these things that Mayo is describing for its procedure, not just the HCPCS code. The HCPCS code gives you a sort of standard way to talk about what that procedure is. So now we can take the very same process that Amber was talking about before for the codes, and now use those things to link all of the codes together for all the things that they refer to. And now what we have is a structure for the HCPCS code. So it's not just the word joint device, it's actually pricing, the BTOS, the CMS, and so on. There's actually a lot of structure to that HCPCS code. When Mayo mentions this, they're not saying one thing. They're actually saying about 5 or 6 things. What 5 or 6 things are they saying? Well, it's all that stuff that you can find in the HCPCS code spreadsheet.
Exactly. So go ahead.
Okay, so then the next one. Actually, let's let you talk to this one, Amber.
Okay, so we were able to take all of that information that Dean and I have been talking about using the Sparkle query engine on data.world to construct this information into an RDF format. So now we have all of this information that was originally in an unstructured text file, kind of hidden on the CMS website, and we've brought it up to 4th star of open data. It now has URIs to denote things, which is great. We're on our way. We've got 1 more star. If we can get it to linked RDF, if we can link it to other data, we're golden. So what we're going to try to do now is link it to other data. So what we started doing, I mentioned earlier, we were pulling in data from hospitals across the US to connect to all of this information. We'll use an example here, as we have been from the beginning, with information directly from the Mayo Clinic's Rochester campus. So again, as you've been seeing throughout, the Mayo Clinic has a specific column for code, and they add sort of several letters at the beginning to indicate which type of code this is, and then they give you the actual code number at the end. So we're going to use this information to link this CSV file from Mayo Clinic to everything we now know about HCPCS codes. So when we're looking at that 1 row of information from the Mayo Clinic, there's a lot of information we can pull out. For instance, we can say that the enterprise procedure code, really the Mayo-specific procedure code, is this very long string of numbers. It is labeled using this system that I actually don't know what it means, but it means something to the people at Mayo. And this is identified by that HCPCS code. There's a lot we can learn about this good or service in this 1 row of data from Mayo. So now we can follow our same process that we've been going through already. The first is to create a URI. So, Dean, you want to talk through this one too?
Oh, sure. So the procedure code we know is unique amongst Mayo. That's Mayo's own procedure code. That Q11301, this is a code for the Mayo Rochester campus. Now, where are we going to get something for that? We could have just put the word Mayo Rochester in and just made it human readable, but we never know. Mayo might have 2 different campuses in Rochester, or somebody might have a different name for it. So there's a service out in the linked data world, a thing called Wikidata, where they're actually curating data about well-known things. And guess what? The Mayo Clinic Rochester campus is one of these well-known things. And so one of the things that the Wikidata team is doing is to maintain and guarantee to us the uniqueness of the codes for these things. So we have borrowed this. One of the things about linked data on the web, you should always borrow things, work that other people has done. We're going to come back to that theme at the end of this talk. So we're borrowing the identification service that Wikidata has done for hospitals and clinics all around the world, not just here in the US. And then we combined that with Mayo's own unique code. And again, we have an identifier that is unique across the world. The rest of the stuff up to the left are things going all the way to spec.edmcouncil.org. These are the namespaces that we're controlling. But how do we make sure it's unique? We're going to borrow uniqueness of the Mayo Clinic from Wikidata. We're going to take Mayo's own uniqueness for their product codes, slam that together and make sure we have an identifier that is unique for this good or service.
Perfect. So that helps to make sure that we know exactly what we're referring to. Now, there's other information in this row of data that we can include as well. So we have the label from the Mayo Clinic. So we can add that as an RDF label here as well. We recognize that this is identified by a particular HCPCS code. So we can include that URI to the appropriate HCPCS code. Now, it's really important to note here that when we structure the URI to refer to a specific HCPCS code, that we do it in the same way that we did several slides ago when we were showing you how we created URIs for the overall industry level HCPCS code. So you can think about this, if you're more familiar with tabular data than sort of graphical data, you can think about it as like a column that you would use to join two tables, like a key. You want those two keys to be able to match up so that you can link all of their information together. This is the same idea. If these two things are exactly the same, now they're linked. So we can go even further beyond that. We can recognize that this information has been identified by that HCPCS code, but Mayo has given us even more information. They've given us a price specification, which is actually a range showing both the minimum and maximum amount that they would charge for a particular good or service. We can also show that this information, this good or service, was provided by, again, that hospital. And here we're linking to the Wikidata URI once again. Now, there are plenty of other services out there. We could have used something like the URI for Mayo Clinic from DBpedia or another source. We just happen to be using Wikidata here. But again, that allows us to connect to other resources with more information.
So here is what it looks like when you bring it all together. So here at the top, you see that this is our URI for a particular procedure or good or service. We're calling these provisions from the Mayo Clinic. We've talked about how that is unique. And now we've brought together information from all over the spreadsheet that Mayo publishes. You see its type is a provision. That's this generalization of good or service. There's its label. It's provided by the Mayo Clinic. These are all the things that you saw Amber talk about on the previous slide. But now at the bottom, you'll see this thing offers. Well, it turns out that many rows in this spreadsheet talk about a particular offer. If you're being covered by United Healthcare, we have this offer. The offer has a price specification and other details about it. So now you've taken what was originally a bunch of rows in tabular data, and we've split them out into a structure that says this part of the table is about an offer. This part is about the provider. This part is about the procedure or good that's actually being provided. And now, rather than just seeing 45 labels of column headers, you actually have a structure. Some of these go together. And what happens when you have multiple rows? These go together in this particular form. And you see over on the right, and you're here on my mug, we've now achieved our 5-star data. What does that mean? Yeah, well, yay. That means that we have an identifier for each of these things. Those identifiers are linked together, and the linkages between them, words like offers, words like has price specification, tell you how these things relate to each other and how that relates to other things in the world. Now, if we go to the next one, so let's look at that United Healthcare one. Yeah, that where we've got, again, it's unified. This is the Mayo Rochester campus offering of a particular procedure, the one that's given by that number, when it is paid by United Healthcare, and the price currency that this particular price spec is given in is US dollars, and there's the base price, and then the item that's being offered, we can now move back a level. That's the same good or service that we saw before, and the division is offered by, guess what? This is by the United Healthcare. They're the ones who are offering to pay for this. So we now have a lot of structure telling us these things rather than this one big table. So let's go to the next slide. So there's a big so what here. Oh boy, Dean and Amber have been playing around with all this stuff for a while. What's in it for me? Well, there's a couple of ways to think about this. First of all, let's suppose that you've got a business where you want to manage prices and offerings of healthcare services in the United States, and you say, what are all the things I need to know about? Well, you could do the same work that we did. You go to Mayo, you look at this thing, you figure out what the column headers mean, and you go and you see that HTTPS code, you realize HCPCS is actually about 7 codes in a little starburst pattern, and you'll figure all that. You'll get that little text file that Amber showed at the beginning, you'll parse it, you'll do all that. Now, wouldn't it be nice if it were possible when somebody did that kind of work, like parsing that little table that Amber began with, or figuring out how to split HCPCS C1776 into a pointer off to the HCPCS code and another pointer off to another code, because these relationships are actually different, that somebody could reuse that work. And that's sort of the big idea of the web and of data on the web. If I can be a good data citizen on the web, by taking data that's kind of obtuse and annoying, work on it a bit for my own value. And when I'm all done, I can say, you know what? I'm a public benefit corp, or I'm just an all around good person. I'm going to offer this back to the web the same way you make a web page that's got a list of your bookmarks or something like that in a document, then you can share it out. But if in documents, we do this with HTML. With data, how do we do it? We do it with 5-star data. We do it by assigning URIs to things, by linking them together with RDF, publishing that RDF through some publishing service like data.world. And we can put it on the web too, but data.world gives you a lot of capabilities to query and search things. Can we go to the next slide, please?
You got it.
And so now I'm getting my other mug, the Fair
You have so
Data
many mugs.
mug. I'm such a mug here. The Fair Data mug. So the Fair Data principles. Amber and I were doing this thing. Well, gee, if I wanted to do what Dean and Amber are doing, how would I start this? And yeah, there's a lot of technical work we did. The Amber mentioned a script that was scraping something or other, and we have all the Sparkle stuff, and there's a lot of technology there. And use your own poison for that sort of thing. But what are we driving for? And this is what Fair Data is all about. And you see the 4 letters here, and we're near the end of our time, so I'm just going to summarize these things. So first of all, let's be findable. How does somebody find this data? Amber and I have done this stuff with HCPCS codes and the Mayo codes and so on. So we need to put this out there with some metadata to say, what are we talking about? And data.world provides a way for us to do this. So does a web search engine, but data.world gives you that sort of that nice little special data specific search engine. If someone wants to access this, they want to run queries against it, they want to build an API against it, they actually want to have that available, that's, again, data.world provides this whole API, a structure for managing queries. You saw bits and pieces of that here. And now interoperability. This is really the key to turning this data into something that's useful to society as a whole. In principle, the HCPCS codes were available to every clinic. Now, of course they are. They're all using them. But how do I find out when I look at Mayo and I look at Anderson and I look at Wexner and I look at these other clinics, how do I know what they're looking at? This is where the global identifiers come in. We made a quick decision, said this is the EDM Council's publishing this, somebody else could do the same. But now we have a place to go to say, let's use their version of HCPCS code. So that's the interoperability. And then finally, reusability has to do with licensing and sharing. For all these things that we mentioned at the very beginning, some of them are licensed, we can't republish them. Others are free of a license, and we can republish those things. One of the things you have to do when you're republishing data is make sure you put that license on there so that people know what they can do. And that's the R of FAIR. So these are the principles that can guide you. There's a lot of technology there. We'd really be happy to talk to you about how data.world can help you with that. But the idea is when you make your data fair, now anyone in the world can find it, they can access it, they can interoperate it with their data, and they know what their responsibilities are. Okay, one more slide, Amber.
And we're
I think
at
I
the
made
end.
it just under the wire.
It was beautiful.
Yeah.
Yes.
So
well, we
make
hope
your
this
data
was
more
helpful.
fair and check out our open community to see some of the stuff we're doing.
Yeah, wonderful. Thanks, y'all, for listening.